Hello, welcome to my differential equations full review. So let's get started. If dy dx is equal to k over x, k is a constant, find y when x is equal to 2. Alright, so let's do some very basic separation of variables here. So dy is equal to k over x dx. Just moving the dx to both sides, then you integrate. So integrating the left-hand side, you get y is equal to k ln x plus c. Alright, and so now we have to do the specific part of this. So if y is 3, alright, so 3, and when x is 1, find y when x is equal to 2. Okay, so let's do 3 is equal to k ln 1 plus c. Well, ln 1 is 0, so it doesn't matter what k is. C is 3, because ln 1 is 0. So now we've done that, we can probably substitute more information into the other stuff to get what we need, I would assume. So y is equal to 8 when x is equal to e. Alright, so I guess we're going to use that to find k. So y is equal to 8. So 8 is equal to k ln e plus c, which is 3. Well, ln e is equal to 1. So that's just 1. And if we say solve for k here, this is just subtract 3 from both sides. So h minus 3 is 5, and k is equal to 5. So now we have all of the information we need to substitute and solve for when x is equal to 2. So y is going to be k, which is 5, ln 2, because that's our x, plus c, which is 3. And that is our answer. You could put that into a calculator, but alright, next question. The rate of change of y is proportional to y. So that sounds dy. Alright, and there's going to be some x's, so we're going to do dy dx is going to be equal to some proportionality of y. So we're going to do just some proportionally constant k, y. And so then we're going to basically do what we did in the last problem and do some separation of variables. So divide both sides by y, dy over y is going to be k dx. To get rid of the differentials, you integrate both sides. You get ln y is equal to kx plus c. We exponentiate both sides to get rid of these logs. And then we get y is equal to e to the kx plus c. But we can pull this c out front because it's just another constant. So y is equal to big C e to the kx. Alright, so now we have that. We need to start looking at these values. So when x is equal to 0, y is equal to 24. So 24 is equal to some number c, but x is equal to 0. So e to the k times 0. Anything times 0 is 0. So that's just e to the 0. And e to the 0 is 1. So 24 is equal to c. That was easy enough. And then, so now we've solved for c. And now when x is equal to 2, y is 38. So we're going to set y to be 38 this time. And we're going to solve for k. So we have 24 is e to the k times x, which is 2. Now we divide both sides by 24 to just leave the exponential. So 38, that is a 2. Try that again. 38 over 24 is equal to e to the k, e to the 2k. Take the natural log of both sides to get rid of these exponentials. ln 38 by 24 is 2k. Divide both sides by 2. So this over 2 is equal to k, which is approximately 0.2298. 2298. Here we go. And so now we want when x is equal to 10. So we want, here's our y. So we're going to say 24 e to the 10 times k, which is this 10 times 0.2298, which is about 238.8. Water is leaking out of a large barrel proportional to the square root of the depth. Alright, so we're just going to call the depth like h or something. So dh dt, because this is over time, is proportional to the square root of the depth. So proportionality and the square root of h. And then do some algebra here. We're going to do dh over the square root of h. And actually, I'm going to just write this as h to the minus 1/2. Just to save some time. This is going to be kdt. Just by moving that to the other side. We're going to integrate both sides. And this side we already know is kt. But over here, we add 1 to the exponent. So 1/2 plus 1, or negative 1/2 plus 1 is now 1/2. So we're going to have h to the 1/2. And then we are going to divide by the new exponent. So dividing by 1/2 is the same thing as multiplying by 2. So now, and then we need to have our plus c on the other side. Alright, so now divide both sides by 2. So we have h is kt plus c all over 2. This is also square rooted, so we need to square both sides to actually get h there. So if the water level starts at 36 inches and drops to 34 in 1 hour, so we have the water level starts at 36. Okay, so h is 36 at t equals 0. So k times t is 0. 0 plus c over 2 squared. So 36 is equal to c squared over 4. And then doing algebra, we multiply the 4 over and take the square root. But we're just going to say 36 times 4, which is 6 squared times 2 squared. So taking the square root, we already know that c squared, or that is equal to c, which is equal to 12. So c is equal to 12. All right, then we can use this information. Drops to 34 inches. So 34 is our new height, and that is going to be equal to what? We still don't know k, but we do know c. So we have k times t of 1 hour. So that's just k plus c is 12. All of this is squared. So we can move the 4 over to the other side. So that is going to be 34 times 2 is, not times 2, times 4 is equal to k plus 12. The quantity, that looks like a 1 on the other side. K plus 12 quantity squared. But we can square root this side. And we know that this is 2 times 2. So we can pull out a 2. So this is 2 square root 34. Is equal to k plus 12. Moving 12 to the other side and just entering this into the calculator, we get that k is approximately negative 0.338. But we need to have it drain all the way out. So when that occurs, the final h is actually 0. So 0 is going to be equal to k times t squared. So negative 0.338 times t. We don't know what t is. We're solving for t. Plus 12 over 2. And this is all squared. All right. We can now multiply the 2 squared to the other side because it doesn't really matter. So it's still 0 is the negative 0.338 chi, 12 squared. Then we can square root and subtract 12. So take the square root of both sides. The square root of 0 is still 0, and then we can subtract 12. So, or move this to the other side. So now I'm just going to stop writing the thing. We know what k is, but I'm just going to write kt is equal to 12. And then we can divide both sides by k, and t is now 12 over 0.338. It's actually positive now, so it's not negative. 338. So now this is about 35 hours. 35.5 hours. Here's an interesting problem. The rate at which ice melts into a small pond is given by dv dt. So now we have that. So what is the amount of ice that is melted in 6 minutes? So we know that dv is going to be this square root 1 plus 3 to the t dt. And integrating this side will give us v, but we want the first 6 minutes, so we go from 0 to 6. And this, if you look at the integral here, we can't really use a u sub because we don't have the derivative of this on the outside. I thought that was my circle tool. And we can't do integration by parts here effectively. So the best method for this is just shove it into your calculator. And this is thankfully a calculator question. So this is about 48.15. See, nearest cubic foot. All right, so we're just gonna do 48 feet cubed. All right, 3 months after a car dealership stopped advertising, its monthly sales decreased from 312 to 208 vehicles per month. If the sales continue to do the same, what will they be at another 2 months after? All right. So it decreased from 312 to 208. 3 months. So at time 0 months, it's 312 vehicles per month. So we have our form. Should this be just like y, I guess? Why is my pen in yellow? Y is equal to c e to the kt. We know it's going to be in this form. So if y is our monthly sales, and we have 312 is equal to c, and then this is our first month, or our 0th month, technically. So e to the 0 is just 1. E to the 0, so c is just 312. Awesome. Okay, so now it decreased to 208. So now we have y is, actually for the third month, it is 208. So 208 is our number of vehicles sold per month. And so this is now C times e to the kt, but we have our c, so we have 312 e to the kt. We don't know our k, but we do know our 3. Our t, it is 3. So 3k. Now we can solve for both sides by just dividing both sides by 312. So 208 over 312. And that gets rid of the 312. That's e to the k, e to the 3k. We can take the natural log of both sides to get rid of our exponentials. So ln of, that's just 2/3, isn't it? 208 divided by 312. So ln 2/3 over, I'm not gonna do that quite yet. We're gonna say e to the natural log of e to the 3k. The e and ln's will disappear on the other side, leaving just 3k. Divide both sides by 3, so that k is equal to ln 2/3 over 3, which is about negative 0.135. Let's see here. What about 2 months after? So not at 2 months, 2 months after this. So that is actually t equals 5. So I will do this in green. Sure. So we need to find our sales now, but we have the other information. So C is 312 from our initial condition. And next up, we do our e to the negative 0.135, because this is k times t, which is 5. So now y is about 158.7, but you can't have half of a car, so y is 159. 159 vehicles will be sold. All right. Now we have a Euler's method question. Use Euler's method. Lovely. All right. So I like my x, y, and dy tables because it just helps me stay somewhat organized. I already know my dy is going to be a lot longer than my other one. So starting at x equals 0, boom. F of 0 is equal to 1, boom. All right. That's the easy part. So now dy is just our dy dx, I'll just write y prime, plus, sorry, not plus, times our delta x. And then we're going to just have this, and then maybe even another column just to add uh, our previous y. But we don't have to do that. So, and what is our step size? 2 equal steps to approximate negative 0.6. So our delta x is actually, let's write this down. Our delta x is negative 0.3. That is an interesting one. All right, I have not seen this before. Or I've not done one exactly like this, but our algebra should be exactly the same. So, let's get started. What is our dy? So x is 0. Boom. 0 plus 2 times 1. So 2 times 1 is just 2. And then we're going to multiply this by our negative 0.3, which is negative 0.6. So we will add this to our y's to get our new y's. And we know this is negative 0.3 and negative 0.6. So add this to our previous y. 1 minus 0.6 is 0.4. So now we can substitute our values in. So x is negative 0.3, negative 0.3 plus 2 times y is 0.4. And then we're going to multiply this by our negative 0.3, which is negative 0.15. And then we're going to add this to our 0.4, which is 0.25. And we can stop now that we have approximated negative 0.6. So let's just write f of negative 0.6. And this isn't the exact answer, obviously. It is 0.25. That's about 0.25. Alright, so here's another Euler's method problem. But at the end, we're going to find the error by actually computing it. So let us get started. So 2 equal steps. We start at 0, so our delta x is 0.4. So let's just write this over to the side. We want to find 0.8, and we start at x equals 0. 2 steps, meaning 0.4. Alright, x, y, and dy. It's just my favorite way to set up these tables. It is the most effective, in my opinion. So we're going to start at 0 and 5. And so what is dy? That is, we're just going to be looking at the x's. So we have negative 2, is 0 minus 2, times our delta x, which is 0.4. And now we're going to add this. This is 0.8, or negative 0.8. Negative 0.8. And so this is 0.4. And this will be 0.8. So 5 minus 0.8 is 4.2. 4.2 minus 2 is 4.2 minus 2. is we are doing 0.4 minus 2 because we're looking at our x's, not our y's. Pay attention to what you need. 1.6 minus or times 0.4 is now negative 0.64. And then add this to 4.2, and this is 3.56. So using Euler's method, y of 0.8 is about 3.56. Now we're going to actually solve our differential equation on the right-hand side here. So if we separate the variables, we have dy is equal to x minus 2 times dx, and then we integrate both sides. Y is equal to x squared by 2 minus 2x, just using the power rule here. And then every good antiderivative deserves a plus c. But we know that y of 0 is equal to 5, so c is equal to 5. And so we just can say x squared by 2 minus 2x plus 5 is our y. And now if we just substitute it in our 0.8s here, 0.8 squared by 2. What in the world is that symbol? Is equal to, not equal to, minus 2 times 0.8, 0.8 plus 5 is 3.72. Now, our error is actual minus the expected. We're not doing percent error, this isn't chemistry or physics, we're just doing the change, the difference. So the actual from the actual calculus is 3.72, so error is going to be 3.72, 3.72 minus 3.56, which is 0.16.